Dear friends, welcome to your personalized podcast. Today, we dive into the rapid evolution of large language models, the challenges founder CEOs face in scaling startups, and how advanced build systems are transforming software engineering. Let's explore these fascinating topics together. Where are we with AI today, and what might come next? Let's delve into the world of large language models, or LLMs, which power chatbots like ChatGPT and Gemini. These models are becoming increasingly smarter, so understanding why can help us predict future developments. LLMs are all about scale. The larger the model, the more capable it usually is. Larger models have more parameters, which are the values they adjust to make predictions. These models are trained on vast amounts of data, measured in tokens, which are often words or word parts. Training these models requires immense computing power, often quantified in floating-point operations. A larger model trained on more data can perform more complex tasks and generally appears smarter. Take Bloomberg GPT, for example. Bloomberg created it using their vast financial data resources, training it on 200 zettaflops of computing power. Although it was adept at analyzing financial documents, it was outperformed by GPT-4, which wasn't specifically trained for finance, but was simply a much larger model, estimated to be 100 times bigger and trained on 20 yottaflops. This demonstrates that scale can significantly impact a model's capabilities. Larger models not only require more data, but also more computing time and resources. For every tenfold increase in model compute, researchers found that translators completed tasks quicker and earned more per minute. However, this improvement comes with increased costs and resource demands. Each generation of models requires a substantial increase in data and computing power, making them expensive to train. Currently, the largest models are known as frontier models. For simplicity, let's categorize them into generations. Generation 1 models, like ChatGPT 3.5, require less than 10 to the power of 25 floating-point operations and cost around $10 million to train. Generation 2 models, like GPT-4, need between 10 to the power of 25 and 10 to the power of 26 floating-point operations with training costs around $100 million or more. Upcoming Generation 3 models, expected around 2025 to 2026, will require even more computing power and could cost over $1 billion to train. Generation 4 models might push these boundaries even further. Among the current generation, 2 models, 5 stand out. GPT-4o, which powers ChatGPT and Microsoft Copilot, is multimodal, meaning it can work with voice, image, and files, and produce code. Claude 3.5 Sonnet excels with large texts and can output small programs. Gemini 1.5 Pro from Google is partially multimodal and can handle text, voice, images, and even video. Grok 2 from Elon Musk's XOAI integrates with Twitter and can generate images through Flux. Lastly, Llama 3.1405B from Meta is unique due to its open weights, allowing anyone to download and modify it. Recently, a new form of scaling has emerged: the thinking process. OpenAI's O1 preview models achieve remarkable performance by performing multiple internal reasoning steps before producing an output. This thinking scaling law suggests that the longer a model thinks, the better its answer will be. This new approach shows that AI can still improve by allocating more computing power to this thinking process. In conclusion, the dual scaling laws for training and thinking indicate that AI capabilities are set for significant advancements. As we continue to develop larger and more efficient models, the potential for AI to tackle complex problems with minimal human intervention grows. This ongoing race for more powerful AI promises to bring both opportunities and challenges. Speaking of evolving challenges, let's now explore the journey from startup to scaled business and the unique hurdles faced by founder CEOs. What makes the journey from a startup to a scaled business so challenging for founder CEOs? This question has been a hot topic lately, especially after Paul Graham's article on founder mode stirred up conversations in the tech community. I recently had dinner with some product leaders in Berlin, and we found ourselves deep in discussion about how product teams can better collaborate with founder CEOs. This relationship is often a source of tension, and I'm concerned that Graham's insights might add fuel to the fire. Graham rightly praises founder CEOs for their vision and drive, but his article misses crucial aspects of scaling a business. This oversight could potentially undermine the contributions of non-founder leaders. Having worked closely with founder CEOs through board work and consulting, I've seen firsthand how the path from startup to scale-up can be fraught with difficulties. In the early days of a startup, everything feels electric. Small teams work tirelessly, pivoting quickly to meet customer needs and secure those first essential sales. Processes are loose, and standardization is usually an afterthought. It's an exhilarating phase, one that I've experienced in several early-stage startups. However, as companies grow, the landscape changes dramatically. Scaling introduces a new set of challenges. The focus shifts from simply gaining initial customers to growing and retaining a large user base. Product offerings need to expand, and operations must run efficiently on a much larger scale. While innovation remains crucial, it can't come at the expense of the core business, which now supports hundreds or even thousands of customers. Many founder CEOs struggle at this stage. They find it difficult to transition from a do-whatever-it-takes mentality to a more strategic, delegating role. I've seen billion-dollar companies get acquired for a fraction of their worth because their founders couldn't adapt. Graham criticizes the advice often given to scaling founders. Hire good people and give them room to do their jobs. Founders frequently misunderstand this to mean they should completely step back, letting others make all the decisions. This approach lacks context and isn't really a strategy. Founders often set a lofty vision, such as, make the world a better place for doctors. But this is too vague decision-making. Companies need a clear strategy to focus their efforts. Without it, organizations tend to fragment, with departments like product, marketing, sales, and engineering working in isolation. This lack of unified direction can be disastrous. A common pattern I see is founder CEOs chasing new innovations at the expense of the core business. They distract teams with shiny new projects, ignoring technical debt and user experience issues. When metrics decline, they often blame the product team for a lack of innovation, not realizing their own actions contributed to the company's struggles. Founder CEOs usually don't inherently know how to run large organizations. They often lack prior executive experience and are learning on the job. The most successful ones, like Mark Zuckerberg at Facebook, actively learn and adapt. They surround themselves with experienced leaders and are open to evolving their leadership style. They recognize that scaling requires different skills and are willing to grow into their roles. The best founder CEOs I work with are eager to learn how to set strategy and execute it well. They hire leaders to fill in their gaps and rally the company around a clear vision and mission. On the other hand, less successful founders often play the blame game, pointing fingers at others for their own shortcomings. They create discord within their executive teams and resist evolving with their new roles. As companies scale, the role of experienced product leaders becomes critical. These professionals work closely with executive teams to allocate resources effectively, balance innovation with maintaining core products, and manage the increased risks of a growing customer base. They help set company priorities through rigorous data and customer research, bringing a structured approach that complements the founder's vision. The key to successful scaling lies in finding the right balance. Founder CEOs need to provide a clear vision and strategy while allowing their teams the autonomy to execute. They must trust their experienced hires while staying involved enough to ensure organizational alignment. Some founders even recognize when they can't provide what the company need and step back into less demanding roles. While founder mode has its place, especially in early-stage companies, it's not a solution for the challenges of scaling. By recognizing the unique demands of growth, embracing the expertise of seasoned leaders, and committing to personal development, founder CEOs can navigate the transition from startup to scaled enterprise. This approach not only honors the founder's original vision, but also leverages the diverse skills needed to build lasting companies. Now that we've explored the challenges of scaling a startup, let's turn our attention to the issues engineering organizations face with slow and inconsistent software builds, despite modern DevOps advancements. Why do software builds take so long, and what can be done to speed them up? Despite significant advancements in DevOps tools, many engineering organizations still struggle with slow and inconsistent software builds. Tools like Docker, Circle CI, and Terraform have revolutionized containerization, continuous integration, and infrastructure management. But the complexity of modern software projects is growing. Many teams are now using monorepos and pulling in numerous third-party dependencies, which complicates the build process. Circle CI reported a 97% increase in daily workflow volume for top-performing teams in 2024, illustrating this trend. This complexity often results in slower builds and increased build failures, creating a bottleneck in the development process. A software build is the series of steps required to compile and test code. Engineers can initiate builds locally or through continuous integration systems. Slow builds are a major issue because they delay development and increase costs. Imagine starting your workday only to find that a fresh build takes an hour due to cache misses. Long, continuous integration builds can block pull request merges, and onboarding new developers takes days because of environment inconsistencies. These issues frustrate developers and inflate infrastructure bills. In Stack Overflow's 2024 developer survey, quality developer environments and build environments were ranked as two of the most important factors for job satisfaction. Advanced build systems are emerging to address these challenges. Traditional build tools like Unix's Make, CMake, and Maven have been around for decades. But newer systems like Google's Bazel, Meta's Book, and X's Pants are pushing the envelope. These systems, originally developed by big tech companies, support speedy builds through effective caching and remote execution. They have been open-sourced, leading to a wave of startups offering complementary solutions. Companies are adopting these advanced systems to improve developer velocity, reduce infrastructure costs, and ensure build consistency. New build systems achieve significant speed improvements by subdividing builds into smaller targets, managing dependencies deterministically, and leveraging remote execution. For example, Bazel and Book allow developers to define targets through strict build files. During a build, the system scans for changes and only rebuilds the affected targets, drastically reducing build time. Deterministic dependency management ensures that builds are consistent and reproducible by using precise version pinning and cryptographic hashing. Remote execution further speeds up builds by distributing tasks across multiple machines and caching outputs to minimize redundant work. Monorepos, which store all of a project's code in a single repository, are becoming more popular. They offer advantages like easier code searches and standardized practices, but also present challenges, particularly with dependency management. Tools like NX, TurboRepo, and RushStack help manage these challenges by optimizing monorepo builds. Consistency and security are also driving the adoption of advanced build systems, especially in compliance-focused sectors like finance and aerospace. Nix, for example, offers strong consistency guarantees through its functional package manager and is gaining traction as a reliable build system. Startups like Flocks and Determinate Systems are building enterprise tools on top of Nix to further enhance its capabilities. However, not all teams need these advanced systems. They often come with a steep learning curve and can require significant refactoring of existing code bases. Small teams with modular code bases might find the investment too high. For these teams, using newer package managers or continuous integration tools that offer caching and parallelization can be a more practical solution. The trends that necessitate advanced build systems, third-party package adoption, monorepo growth, and continuous integration and continuous delivery expansion are here to stay. Even companies outside the traditional tech industry are starting to adopt these systems. As these tools become easier to integrate, more companies will benefit from them. The main takeaway? Advanced build systems might finally end the era of "it worked on my machine." By offering faster, more reliable builds, these tools will change how developers work, making slow builds a thing of the past. That's a wrap for today's podcast. We explored the rapid evolution of large language models, the challenges of scaling startups, and how advanced build systems are transforming software development. Stay tuned for more updates. Dear friends,